When GE decided to step into the locomotive market, they weren't doing it quietly. They came in like a company with something to prove. They were finally ready to challenge EMD, which was the builder everyone else had spent decades chasing, and railroads noticed. They were hungry for a competitor, for fresh engineering, for someone bold enough to push diesel power into its next era. That's what the U-boat series promised. From the U-25B to the later U-30s and U-33s, GE sold these locomotives as the smarter option, with more horsepower, better fuel economy, and modern electronics. Everything the industry said it wanted. On paper, it looked like the long-awaited shakeup, the kind of change that could loosen EMD's grip on the market, and finally give railroads a real alternative. For a moment, it genuinely felt like the future had arrived, but with that promise came something nobody expected, because the same technology that made the U-boats exciting also came with problems GE never saw coming. And what was supposed to be a breakthrough ended up becoming one of the most infamous chapters in their locomotive history. This was supposed to be the future, but it came with a cost no one expected. To understand why railroads were willing to take a chance on GE, you have to look at what the diesel market looked like at the time. EMD had been the undisputed leader for years, thanks to the 567 engine, a workhorse that built the foundation of dieselization. Crews trusted it, mechanics understood it, and railroads could count on it to run thousands of miles without raising their blood pressure. But even the most dependable designs eventually start to show their age. By the time GE entered the scene, EMD was shifting toward the 645 series, an evolution rather than a reinvention. And some railroads felt the company was getting a bit too comfortable at the top. GE saw an opening, and they didn't want to build something competitive. They wanted to build something modern, something that made EMD look like it was stuck in yesterday's playbook. And their pitch wasn't subtle. They promised more horsepower, stronger acceleration, smarter electronics, and better fuel economy. Everything railroads said they wanted, but weren't getting fast enough from EMD. At the heart of the U-boats was the new 7FDL engine. This wasn't a mild upgrade or a reworked version of an older design. It was GE's statement piece. With higher horsepower ratings, quicker throttle response, and better thermal efficiency, the 7FDL promised the kind of performance numbers railroads had been craving, especially as freight trains got heavier and timetables got tighter. On paper, the difference was impressive. Locomotives that pulled harder, burned less fuel, and didn't rely on yesterday's engineering. But the appeal went beyond raw numbers. GE leaned heavily into electronics and marketed their locomotives as the smarter choice. They wanted railroads to think of diesel power the same way consumers thought of new appliances or early computers. Modern, efficient, and built to do more with less effort. The idea of a locomotive that could think through its workload rather than simply muscle through it was compelling, and GE was one of the few companies with the technological background to make that claim sound believable. Railroads were intrigued. They were looking at rising fuel prices, heavier trains, and tighter operating margins. The idea of a locomotive that used less fuel yet produced more power wasn't just attractive, it looked like the next logical step in diesel performance. And unlike EMD, who refined their engines gradually, GE promised to leap ahead in one jump. It helped that GE was already a titan in electrical systems and heavy industry. Their reputation in power generation, turbines, and industrial equipment gave the impression that they were more than capable of designing the next big breakthrough in rail traction. For many railroads, it felt like a safe bet, maybe even the smartest bet. So when GE rolled out the U-boat series, railroads listened. They wanted more efficiency, more horsepower, more innovation, and GE promised all of it in one package. A locomotive built not just for the present, but for the future of American freight. For a moment, it genuinely seemed like GE had delivered exactly what the industry needed. It looked like the beginning of something big until the cracks started showing. On the brochures, they were flawless. In the boardrooms, they were revolutionary. And on the test stands, under controlled conditions, they behaved just well enough to convince railroads that the risk was worth taking. But the thing about progress is this. It's never the laboratory that tells the truth. It's the rails, the miles, the heat, the grit, the real world. And the real world exposed these machines fast. For all their innovations, the new engines carried a silent flaw. They simply weren't field tested long enough. Not in the mountains, not in the deserts, not under the crushing day after day workloads that freight railroads actually deal with. Once they rolled out into service, the problems came, not as a single failure, but as a spreading constellation of small disasters. The first signs showed up on long hauls, usually when the locomotives were pushed hard. Temperatures climbed, gauges crept into the red, cooling systems strained to keep up. Before long, engineers were reporting chronic overheating, the kind that forced trains to throttle back or stop entirely just to let the machinery breathe. A locomotive that couldn't handle heat wasn't just inconvenient, it was a liability. Then came the turbocharger failures. Turbos are the lungs of a locomotive, the key to squeezing more power out of every stroke. When they fail, they don't go quietly. Some locked up suddenly, others shed pieces of themselves into the engine. Mechanics learned to dread the sound, a high-pitched whine followed by a sickening drop in power. But the problems didn't stop at the mechanical level. Inside the electrical systems, something darker lurked. Wires misbehaving, sensors contradicting each other, circuits that worked perfectly one day and acted possessed the next. Railroad crews started calling these incidents electrical gremlins because there was no pattern, no logic, no reliable fix. You could swap out parts, run diagnostics, consult manuals, and still end up staring at a locomotive that refused to cooperate. And then came the failures that weren't just inconvenient, but dangerous. Traction motor flashovers. A flashover is exactly what it sounds like. A sudden burst of electrical energy arcing where it shouldn't. Sparks, smoke, sometimes worse. When a traction motor flashed over at speed, it could cripple the entire locomotive instantly. Trains stalled on grades. Long consists came to unexpected halts in the middle of nowhere. It didn't take long for crews to come up with a nickname. They called them U-boats. Officially, the name fit because of the U-Series designation stamped on their builder's plates. But out on the rails, the nickname took on a different meaning. These engines were hot, too hot. They ran like they were sealed inside their own steel pressure hulls, sweating and straining as if they were trapped underwater with no escape. And once the name stuck, it never left. They looked impressive from the outside. Tall, angular, purposeful machines that promised a new standard in American railroading. But if you asked the people who had to keep them alive, the men working in the pits and shops, those impressions evaporated the moment a U-boat rolled through the doors. Because beneath the steel skin, beneath the marketing language and the horsepower claims, lay a tangled landscape that almost guaranteed frustration. Maintenance crews didn't just dislike them, they hated them. The first complaint came the moment someone opened an access panel. GE had crammed an entire generation of new technology into a body that wasn't designed to hold it cleanly. Everything was packed tight, components layered on components, cables draped over tubing, sensors wedged behind assemblies that should have been easy to reach but weren't. Changing something simple, an injector, a gasket, even a section of wiring, felt like defusing a bomb in a broom closet. You worked by feel more than sight, reaching blind into metal forests where sharp edges and hot surfaces waited to punish mistakes, compared to the clean, open, logical layouts of EMD units. These machines felt like a puzzle designed to make mechanics miserable. And even if you could reach the part you needed, actually getting the replacement wasn't guaranteed. GE's supply chain at the time was still young, still underdeveloped, still years behind the rock-solid parts network that kept EMD's engines thriving. Shops waited days, sometimes weeks for critical components. Some railroads resorted to cannibalizing other U-boats, gutting one to save another, creating a growing boneyard of half-scrapped locomotives waiting for the impossible part that never seemed to arrive. The parts that did come were expensive, sometimes shockingly so, turning every repair ticket into a painful conversation with management. The result was predictable: constant downtime. These weren't engines that came in for a quick fix and rolled out again by morning. They sat, they lingered. They occupied precious shop tracks and yard space, resting, while other locomotives did their jobs for them. Railroads began calling them yard queens, machines that spent more time parked than pulling trains. And when a locomotive that was supposed to redefine the industry becomes famous for being motionless, that's not just a problem, it's a warning. Out on the main line, EMD locomotives routinely took over when a U-boat dropped out mid-train. It became so common that crews stopped being surprised. If you had a GE leading and the dispatcher called with trouble somewhere up the line, you already knew which unit had failed. It wasn't a question of if, it was which failure this time. And with that reliability gap came the trackside humor. Railroaders have always used jokes to cope with bad equipment, and GE's early diesels became easy targets. The favorite line spread from shop to yard to crew room until everyone knew it. If it's a U-boat, expect a tow. It was meant as a joke, but like all railroad humor, it was born from experience, and the experience wasn't flattering. The moment the U-boat rolled off the assembly line, expectations were sky high. Railroads had been promised a revolution, smarter engines, more power, better fuel economy, and a new challenger to the long-standing dominance of EMD. But as the first units entered service, reality began to diverge sharply from the marketing pitch. Railroads were quick to notice that the machines, while impressive on paper, were unpredictable in operation. Breakdowns were frequent, repairs were complex, and availability rates fell far below what crews had been led to expect. Locomotives that were supposed to pull freight reliably now often became the center of headaches. Dispatchers and shop supervisors began quietly reprioritizing orders, turning back to the EMD units that, for all their conventionality, offered a level of predictability no new technology had yet matched. The U-boats, once symbols of innovation, were quietly reassigned to lighter duties, or pushed into secondary service, where their shortcomings could be tolerated. Yard work, local runs, and short-haul assignments became the preferred environments for these engines, far from the sustained high-power operations that had been intended. In effect, the fleet that was marketed as the future was slowly being sidelined. Yet, even as railroads distanced themselves, the story wasn't finished. GE's engineers, far from seeing defeat, scrutinized every failure. Each overheating unit, every electrical fault, every turbocharger failure became a source of insight. The very incidents that had frustrated crews provided raw data on operational limits, component weaknesses, and integration challenges. While the locomotives were proving costly in the short term, they offered lessons that no lab could replicate. The U-boats were acting as a brutal, real-world testing ground, revealing the difference between engineering on paper and engineering under the stresses of day-to-day railroading. In a sense, the U-boat's tarnished reputation was only part of the story. Behind the scenes, GE was taking notes, redesigning cooling systems, rethinking component layout, and analyzing electronics for serviceability. The failures highlighted gaps that had been invisible in development, and for a company determined to compete, those gaps became opportunities. What railroads viewed as setbacks, GE recognized as the blueprint for improvement. In hindsight, the engines that were derided as unreliable were shaping the design philosophy that would later define an entire generation of successful locomotives. By the time the next series of engines appeared, the lessons of the U-boats were fully integrated, ensuring reliability and performance that could finally rival and in some ways surpass EMD. The U-boat fleet faded from prominence, but it left an indelible mark. The machines themselves may have been sidelined, but the knowledge they generated became the foundation for GE's future. Every breakdown, every part replacement, and every frustrated mechanic contributed to a growing understanding of how to build locomotives that could handle real-world railroading at scale. The short-term damage to reputation was severe, but in the long view, these early missteps proved essential. GE's early failures were, paradoxically, the seeds of long-term triumph, proving that even a high-profile misfire can carry the lessons necessary to dominate an entire industry. GE didn't respond to the U-boat setbacks with hesitation or retreat. Instead, they treated each failure as a roadmap for reinvention. Cooling systems were redesigned, allowing engines to operate at sustained power without the constant threat of overheating. Traction systems were overhauled, improving control under heavy load and eliminating the sudden electrical faults that had plagued crews. Electronics, once densely packed and frustrating to service, were re-engineered into modular, smarter layouts that could be repaired efficiently without extensive downtime. Each adjustment addressed a specific weakness, but collectively, they transformed the approach to locomotive design. The lessons learned from the U-boats became the blueprint for GE's next generation of machines. The Dash 7 series was the first to benefit, bringing reliability, power, and serviceability that railroads could trust. From there, the evolution continued. Dash 8, Dash 9, and ultimately the Evolution series emerged as the products of painstaking refinement. The failures of the past had directly informed design choices, creating engines that combined the advantages of power, efficiency, and maintainability. What had once been a liability, the U-boat's notorious unreliability, was transformed into an education in engineering, operations, and customer expectations. By the early 1980s, GE had completed the turnaround. Railroads that had once avoided the U-boats now embraced GE locomotives with confidence. The very flaws that made the U-boats infamous had forged a culture of meticulous testing, careful engineering, and operational foresight. GE was no longer the underdog. It had become the dominant force in North American diesel-electric locomotives. The failure of the U-boats, once a source of embarrassment, had lit the fire that would propel the company to the top, proving that innovation, when paired with relentless learning, could turn disaster into global success. The U-boat didn't just run hot. Every breakdown, every overheating engine, every frustrated crew member became part of a lesson GE couldn't afford to ignore. Those early struggles, harsh as they were, forced the company to rethink, redesign, and perfect their approach. In the end, the U-boats didn't just fail, they forged the foundation for GE's rise to the top of locomotive manufacturing, proving that even disaster can spark greatness. Did you ever operate a U-boat or see one in action? Were these machines legendary beasts or just breakdowns waiting to happen? Share your experiences in the comments. Hit like if you learned something new, and don't forget to share this story with a friend who loves epic machines.